Okay, seventh graders. Looks like this is working. I had an update, so I wasn't sure. Sometimes it doesn't work like I want it to. I'm not going to be here today. I'll be with the eighth graders. We're going to a ropes course, and maybe you guys can look forward to next year. But I'm going to have you guys start 3-5. Somebody will be in the class here with you guys, and I don't know if you just want to put it on the screen, or you guys can each watch it individually. That might be better, just grabbing the headsets and plugging them into your Chromebooks. But we're talking about markups, marks downs, those kinds of things. And you guys pretty much notes from last year. But anyways, I'll just give you an example here for starters. Let's say let's say Mr. Meredith is running. He's running from Mr. Quaylar, who has a shocket stick. He's real happy about that, and it's sending out, lightning. Oh, got him. Okay, and so Meredith is running at, let's say he's running at 15 miles per hour. That's probably pretty quick for a seventh grader, I would think. I'm not sure. I think the fastest a human can run is about 27 miles an hour, maybe 28 miles an hour. So that's pretty quick. And so he's running at 15 miles an hour. But the next day, Mr. Meredith is running from a dinosaur. Okay. It's got really sharp teeth. And he is running faster, quite a bit faster. He's running at 20 miles per hour, which makes sense because he's running for his life here. And so you want to know the percent increase. In other words, how much faster is he running? Let's say this was Tuesday, and this was Wednesday. So how much faster is he running on Wednesday from the T-Rex versus Mr. Quaylar, who's got a shocket stick? All right. Well, how would you do that? How would you calculate that? Well, some of you can just look at this and you say to yourselves, well, he's running 5 miles an hour faster, and you would divide the 5 miles an hour, the difference from Tuesday and Wednesday, divided by 15. And I mean, you could use your calculator, and it's going to be 33%. It's because 5 is 1/3 of 15. So 5 divided by 15 equals, and you get a 0.3 repeated. So it would be approximately 33% increase. Remember, it's always the part divided by the whole equals the part divided by the whole. So you'll have some problems like this. Let's look at some of the examples real quick. Example 1, percent markup. No dinosaurs eating Mr. Meredith in this one. Marty buys plain cell phone cases and decorates them to sell them online at a higher price. What's the percent markup on each phone case? So it says the markup is the amount of increase from the cost of an item to its selling price. And the markup as a percent increase from the original cost is percent markup. Well, that makes sense. It's using the word percent in the markup. So step 1, it says draw a bar diagram to represent the problem and find the markup. Well, here's the original selling price, $7.20, and that's the 100%. Remember, it's always the part over the whole. And this percentage here, this difference here, looks like it's $4.05. And so you're going to divide that by what? By 720, by the whole. And so what do you get? You get a 0.5625 equals the percent. And you're just going to move the decimal 2 places. And so the percent markup on each cell phone case is about 56%. Because that's the question. They want to know what the percent, find the percent markup. So 56%. Look at the try it. What's the percent markup on a $300 phone sold for $465? So it's $165 more. And they're asking again the percent markup. Well, they got 165 equals P times 300. Well, you want to get P by itself to find the percent. And that's what I started to do here. 165 equals 300P. I'm going to get P by itself, so I divide each side by 300. You've seen me do this before. And the 300s cancel out, so we're just left with P on this side. And then you have 165 divided by 300, the part divided by the whole. And you end up with 0.55 or 55% markup. And the markup is, as far as the dollar amount, 165. But it's a 55% markup. Scratch out the convince me at the bottom of page 174, not worried about that. Let's look at example 2. The local furniture store pays $110 for a chest of drawers and sells it with a 40% markup. What's the selling price of the chest of drawers? Well, again, some of you that are a little more math-minded, it's a 40% markup on $110. Well, in my mind, I immediately went to what is 40% of 100? Well, that's going to be $40, right? And what's that leave? It leaves 10. So what's 40% of $10? That's going to be $4. And but if that doesn't, if your mind doesn't work that way, that's okay. You can go ahead and set it up for the selling price. And 110, which is the 100% part divided by the whole. And so it says use the percent equation to find the markup at the selling price. The markup equals the percent markup times the cost. And so 0.4 times 110 equals 44, because if you add 40 and 4, that's going to be 44. The markup is $44. So we have 110 plus 44, because that's the markup. And the selling price of the chest of drawers is $154. Scratch out the try it, not worried about that. Example 3. Edward wants to buy a snowboard that's on sale, and if the sales tax in Edward's state is 7.5%, how much will he pay for the snowboard? So the tax is going to be on top of whatever it's being sold for. So the first step looks like it's on sale. It's 30% off of 180, so that's kind of nice. So the markdown as a percent decrease of the original price is the percent markdown. And so it's going to be 0.30, because you're now changing 30%. That's this right here, 30%. You should know by now. If I needed to change that into a decimal, I start at the percent sign and I move it over 2 places, and that's going to be 0.3 or 0.30. It's going to be the same thing. And unless there's a decimal, and I talked to a couple students about this yesterday, they were, not yesterday, but last week. Let's say the percent markdown was just a little 3.35%. percent. Okay, so when there is a decimal in the percent, then you move it over 2 places from the decimal. 1, 2, so you're going to add a 0. So that's going to be 0, 3, 3, 5. And the decimal goes right there. I moved it 1, 2 places. But when it's 30% or 25% or 99%, you just go from where the percent sign is and move it over 2 places. But anyway, so you can see step 1 and step 2 there. I don't want to take too much time on this. And so it's going to be the sale price 180 minus 54, which is going to be the markdown. And then from there, that's when you calculate the tax, which is 7.5%. Well, what's 7.5% in decimal form? 7.5% equals. So from right here, not from the percentage sign, but from right here, I move it over 2 places. And that's what they did right here. It's going to be 0.075 times 126, because that was the 1/3 or the 30% off. And looks like it's going to be 126 plus 9, 45, 135, 45 for the snowboard. Scratch out the triad at the bottom of page 175. Key concept for 3.5. Essential question: how are the concepts of markup and markdown related to the percent equation? And how are they related? Gosh. Well, you know what? If you just markup equals percent markup times the original value, and if you write down markdown equals the percent markdown times the original value here, I'm happy with that. Number 2 and 3, looks like I answered those for you. Reasoning: what does the amount of markup or markdown represent in the percent equation? It represents the part, and the original value is the whole. Again, it represents the part, and the original value is the whole. And number 3, it says generalized: when an item is marked up by a certain percent and then marked down by the same percent, is the sale price equal to the price before the markup and markdown? And the answer is no, since the value of the whole will change each time. Seems to me we had a problem last week, excuse me, that was like that. Okay, so page 176, circle number 4. I want you to do that one. 5A and B, 6A and B. Next page, 8. If it helps you to fill out these boxes, as I've said before, feel free to do so. But I'm just grading these 2 boxes right here. And then do 9. So let's see here. 9 looks like I set that one up. Karen purchased a DVD player shown in the sign at the right. Find the percent markdown rounded to the nearest percent. So here's it was 175.90. Wow, that's a lot for a DVD player. They've gone down in price over the years. And now it's 153.77. All right. So what do you need to do? Well, first off, you're going to find the difference. So you're going to subtract 153.77 from 175.90, and you're going to get whatever it is. I'll let you calculate that. Whatever that is, you're going to divide that by the whole 175.90. And that will then give you the percent markdown. Number 10. 10A, do that one. Scratch out B, not worried about that. 11 and 12, circle those. 13, A and B, do those. 14, I won't grade, but it is worth a stick if you want to try to figure that out. The sporting goods store manager was selling a kayak set at a certain price. The manager offered the markdown shown at the right, making the one-day sale price of the kayak at $328. Find the original price of the kayak set. I have to zoom in. I can't quite see that. My old eyes. So it looks like it's 10% off. Oh, today only 30% off. I guess they're saying it's a total of 40%. Anyways, so that's worth a stick. And then do 15 and 16. And that's it. I'm thinking I'll probably give you guys a Math Excel for this too. So look for that when you guys come in. And the Math Excel, I think I'll make the Math Excel due today. So you guys will want to work on that and then work on your book here after the Math Excel. And so that's it. Enjoy your day, and I will see you guys on Tuesday, although I might see some of you this morning before we leave.